Continuing with the topic electrolysis, today we are going to study what is reduction. So, children, what is reduction? Reduction is basically a process. It's a process in which an atom or an ion gains electrons. Oxidation was loses electron. Here it is gains electron. For example, you can see here ferrous, not ferrous, ferric is accepting an electron and it is becoming ferrous. So Fe3 plus is changing to Fe2 plus. So it is accepting an electron and as a result of that its Fe3 plus state is changing into Fe2 plus state. So this is called as reduction. Similarly, sulfur atom is accepting 2 electrons and it's becoming a sulfide ion. So this is reduction. Reduction can also be defined as a process which involves removal of oxygen or addition of hydrogen. So you can also define it as a removal of oxygen or addition of hydrogen. It is exactly reverse of oxidation. For example, cupric oxide CuO, it's having oxygen. Now H2 is behaving as a reducing agent. Why? What's a reducing agent? So before, since I'll be using the term reducing agent, so it's better we clarify first what is a reducing agent. Reducing agent is the one that reduces other substances. It reduces other substances. Now, it reduces other substances. How does it reduce other substances? Either by providing hydrogen, either it reduces by providing hydrogen or an electropositive ion. Clear? Or by removing oxygen. So there are three ways to look at it. Either it will provide hydrogen, or it will remove oxygen, or it will provide an electropositive ion. Now here in this case, CuO, it has oxygen. This H2 is a reducing agent. So it is removing oxygen. So you can say CuO is becoming Cu. And the oxygen of CuO is being removed by H2 and it is becoming H2O. So H2O is a reducing agent. Similarly, in the next example, ZNO is carbon coke is a reducing agent. It is taking away the oxygen, removing oxygen, and it is becoming zinc atom. So now another way to look at it, addition of hydrogen. So this Cl2, now H2S is a reducing agent. So it can supply hydrogen to this Cl2 and as a result Cl2 becomes HCl. So it is adding hydrogen to itself. So that is why it is getting reduced. But what happened to H2S? H2S was reducing agent. So it provided its hydrogen to Cl2 and it has become S. So it has got oxidized. Removal of hydrogen. Now second case, Cl2 ammonia. Now what's happening here? Now this equation is known to you. We have done this in ammonia chapter. Now here what you can see, Cl2 is combining with hydrogen. So ammonia is behaving as a reducing agent. Why? Because it is losing its hydrogen and in result of that Cl2 is adding hydrogen to itself and it is becoming HCl. So addition of hydrogen is called reduction. So we say chlorine is getting reduced. Chlorine gas is getting reduced. And how do we say what's happening to ammonia? We say that ammonia is a reducing agent because it's losing its hydrogen. So I hope it's clear, this concept is clear. Now some examples of reducing agent. Now there can be solid reducing agent, there can be liquid reducing agents, and there can be gaseous reducing agent. Now solid reducing agent, carbon, we have seen in the example, and now the active metals like zinc, because they have more affinity for oxygen. This we have learned in metallurgy. You can relate to metallurgy that they have a strong affinity for oxygen. So they take away the oxygen. Liquid hydrogen peroxide, I told you in the previous slide that hydrogen peroxide is a common example. It's a liquid, it's a common example, and you can study it as an oxidizing as well as reducing agent. Now in case of gaseous, it is sulfur dioxide, because sulfur dioxide is a reducing as well as oxidizing agent. So hydrogen peroxide and sulfur dioxide are the common examples which are reducing as well as oxidizing agent. So with this we complete the topic of oxidation and reduction. I hope it's clear to you, and we'll be continuing further in the upcoming videos. Thank you.